Hey everyone, welcome to the VMware Explore 2022 session for the Carbon Black Cloud Data Forwarder. I'm Jasmine Clark and I'll be presenting today alongside Alex Van Brunt. We're both members of the Developer Relations team for Carbon Black and we're excited to share with you today. Let's get started. Before we begin discussing the Carbon Black Cloud Data Forwarder, I'd like to give a brief introduction to the Carbon Black Cloud console. The Carbon Black Cloud is a cloud-native endpoint protection platform, or EPP, that provides what you need to secure your endpoints using a single lightweight agent and an easy-to-use console. Most of today's cyber attacks feature advanced tactics such as lateral movement and island hopping that target legitimate tools to inflict damage. VMware Carbon Black Cloud thwarts attacks by analyzing billions of system events to understand what is normal in your environment, prevent attackers from abusing legitimate tools, and automate your investigation workflow to respond efficiently. Legacy approaches to prevention leave organizations exposed because cybercriminals are constantly updating their attacks. Carbon Black Cloud modernizes your endpoint protection by helping you spot the minor fluctuations that hide malicious attacks and adapt prevention in response. While other endpoint security products only collect a dataset related to what is known as bad, we continuously collect endpoint activity data because attackers intentionally try to look normal to hide their attacks. Today, attackers often bypass traditional endpoint security. Advanced hacking capabilities and services for sale on the dark web compound this issue, making full-spectrum monitoring more important than ever. Carbon Black Cloud simplifies this process by consolidating multiple endpoint security capabilities using one endpoint agent and console, allowing your organization to minimize downtime responding to incidents and return critical CPU cycles back to the business. So what exactly is the Carbon Black Cloud Data Forwarder? The VMware Carbon Black Cloud platform provides SOC teams with visibility into a high volume of endpoint event context, which is critical for detection and incident response use cases. The Data Forwarder delivers that valuable endpoint event data to an AWS S3 bucket, ready for consumption by third-party solutions such as XDR platforms, SIEMs, and data lake tools. The Data Forwarder also has powerful filtering capabilities, putting you in control of the data your organization finds most valuable, while also meeting your team's data budget. It provides consistent, reliable data streaming capable of obtaining large amounts of data in near real time, and provides the opportunity for you to query, analyze, or integrate that data with your other security applications. Now that we have a better understanding of the functionality of the Data Forwarder, we can discuss whether it is the right fit for your organization. There are several solutions provided by the Data Forwarder to meet your organization's needs and accommodate specific scenarios. The most common being that your organization is interested in event and watch list hit data being streamed in real time. With the Data Forwarder, there is no need to call the API directly or pivot into the Carbon Black Cloud console to retrieve this information. Additionally, the Data Forwarder is reliable, guaranteeing data delivery and scalable as your organization grows. The Data Forwarder also allows you to easily integrate with other applications because all the data you need from Carbon Black Cloud is easily accessible through your AWS S3 bucket. Lastly, there are circumstances where it is valuable for organizations to retain data for longer periods of time. Whether it be for data analysis, compliance, or integrations, the Data Forwarder removes the limitation and allows your organization to customize not only the data you ingest, but also the length of time you keep the data. You may be wondering why you should use the Data Forwarder instead of just calling the Carbon Black Cloud APIs directly. While the APIs are perfectly suitable in many scenarios, the Data Forwarder provides some specific benefits that may be a better fit for your organization. The first is data retention. The data retrieved from the APIs is only retained for a standard 30 days. If your organization needs to retain data for a longer period of time, the Data Forwarder provides the option for unlimited data retention through storage in your AWS S3 bucket. Additionally, the data forwarder guarantees your Carbon Black Cloud data will be delivered even during outages and maintenance windows, so the data can easily be reprocessed later. The built-in advanced filtering capabilities of the data forwarder also allow you to reduce events to meaningful value, which saves time during investigation. Lastly, and this is my favorite because I'm type A and I get way too excited about organization, the data forwarder allows you to send data to different folders to target a variety of systems and organize your Carbon Black Cloud data to meet the needs of your organization. You can create custom filters for the data and forward that specific data to custom folders in your AWS S3 bucket. The data in these folders can then be queried or pushed to your other security systems. Maybe you have a folder for alert data and another for event data. Or maybe you have a folder for Splunk and another for a workflow system that creates tickets based on specific criteria. The possibilities are endless, and the best part is that it's completely customizable. You choose the data you want to see, how it's stored, how it's consumed, and how you can use it to make a positive impact on your organization. One of the major benefits of using the Carbon Black Cloud Data Forwarder is that it provides greater visibility and situational awareness by pushing alert, event, and watch list hit data to an S3 bucket to be consumed by other applications. For example, let's say I'm a SOC analyst and I see a concerning alert in Splunk. If I want to gather more information on the related events and processes, and I don't currently have the data forwarder, I would need to pivot into the Carbon Black Cloud console to investigate. With the data forwarder, however, I could configure my system to read from the S3 bucket, which contains all the Carbon Black Cloud data I need, allowing me to view the entire alert context in a single pane of glass. This provides a more efficient means of triaging and analyzing alerts and allows me to effectively make better data-driven decisions. I realize that endpoint events can become noisy, so we've equipped the Carbon Black Cloud Data Forwarder with advanced filtering capabilities, so you only see the data that you need. Maybe we only want to see events that are associated with Carbon Black Cloud alerts. There's a filter for that. Maybe we only want to see certain types of events like netcons or proc starts. There's a filter for that. Or maybe we want to exclude safe, noisy events that are specific to our organization. You guessed it, there's a filter for that. Another valuable benefit of the data forwarder is related to incident response. I'm sure most of you remember the Log4Shell vulnerability, which enabled remote attackers to take control of devices on the internet if they were running certain versions of Log4j. They did this by gaining control over a string and tricking the application into requesting and executing malicious code. Since this type of attack bypasses many traditional security measures, organizations were at risk long before they knew of the vulnerability. The data forwarder provides the ability to forward indicators that the Log4Shell vulnerability is being exploited. Your organization can create custom automation, such as quarantining the device to prevent it from performing other network connections, moving the device to a more restrictive policy, creating a ticket in an external ticketing system, or using a custom Slack integration to notify an analyst or IT admin to patch the vulnerability. Let's take a look at a fictional yet real-world scenario. Here we have Bazinga Solutions, an organization who has purchased 2 Carbon Black Cloud products, Endpoint Standard and Enterprise EDR. They have 200 Windows laptops, 150 Mac laptops, and 750 Linux virtual machines that need to be monitored. We've calculated that Bazinga exports around 1,700 gigabytes of data per day, resulting in approximately $117 per month in data storage costs. I want to show you how we can use the Carbon Black Cloud Data Forwarder's advanced filtering capabilities to not only isolate the meaningful data, but to also drive the storage costs down. Here you can see a table containing estimates of the average Carbon Black Cloud Data Forwarder data volumes per endpoint per day. This table allows us to roughly estimate the cost of storing our Carbon Black Cloud data and provides insight into the types of events we can filter out in order to stay within our organization's budget. Too much data is costly, both monetarily and in wasted time and resources required to sift through it. The goal is not to retrieve mountains of data, but to customize the data to work to our advantage. The data forwarder allows us to do just that. We can exclude the noisy data and focus our efforts on the things that matter. For example, at Bazinga Solutions, they aren't concerned with file mod event types, so they don't even want to see them, and they certainly don't want to pay to store them. The data forwarder provides a simple solution. We can create a custom filter to exclude type endpoint event file mod. If you look at the table here, you'll see the average data volume per day for file mods. We can use this to calculate the amount of savings created simply from filtering out data Bazinga doesn't plan to use. Bazinga has both endpoint standard and EDR, so we can multiply the columns for Windows, Mac, and Linux by the number of those types of devices at Bazinga, and then multiply by 30 to get a rough estimate of the cost and storage savings per month. By filtering out file mods alone, Bazinga can save a little over 10% on their monthly data storage costs. I know saving $115 per month doesn't sound like much, but think of this same example in a larger organization with 50 to 100,000 devices. Storage costs add up, and that 10% could suddenly mean a savings of thousands of dollars. This example is quite general, but as you start to customize your data forwarder experience to match your organization, you will see that the filters can be as general or as specific as you'd like. Maybe you know of a particular process that runs regularly in your organization. It typically poses no threat, and you want to filter it out, but only when it's kicked off by a specific parent process. You don't want to filter out all Python processes, for example, because some could be attacks, but you also don't want to flood your system with events that provide no value. This is where advanced filtering comes in. We can exclude data where the parent command line is service host exe and the process command line is running a specific Python file, in this case, runscan.py. This allows us to reduce noise while still maintaining and prioritizing the health and safety of our organization. I want to show you how simple it is to create a custom data filter. Let's say there's specific data that our team wants to isolate to send to another system. Maybe we want to send all netcon events to a specific folder in our S3 bucket because our network admin team wants to cross-reference the data from Carbon Black Cloud with the data from their networking system. Let's see how we can get that done. If we log into the Carbon Black Cloud console and click Settings, we will see the Data Forwarders menu option. When we click here, we can see a list of existing forwarders and the option to add a new forwarder in the top right corner. To add a forwarder, we first need to select a name. I like to make mine descriptive of the type of data I can expect to see. Next, we need to select the type. For this example, we're going to choose endpoint events. We need to select the name of our S3 bucket and the name of the folder where we would like to push the data. I created a netcon folder under my events folder to hold this data, but you can organize yours in any way that makes sense to you. Next, we want to create our filter. Since we only want to push netcon events, we select type must equal endpoint event netcon. You can also add or remove additional filters from here using the plus and minus button. If we want to add custom filters, we select the Custom Query tab and use Lucene syntax like the examples from the previous slide to create additional filters for this data. You can see that our basic filter was automatically carried over as well. For now, we'll just go with the basic one we created. The status toggle is set to on, so the data will begin forwarding as soon as it's created. You also have the option here to turn it off. Now, we just click Save. As you can see, the forwarder has been saved and set to enabled, and if you scroll to the bottom of the list, you will see our new forwarder. Since the data pushed from the data forwarder is batched and compressed, it won't take up much space in your S3 bucket. However, the data can compound over time if it's not deleted after processing. There are several ways to delete data from your S3 bucket to keep storage size and cost to a minimum. I'd like to review each of these options and show you how easy it is to delete data that's no longer valuable to your organization. The simplest method is to manually delete the data from your S3 bucket. This can be useful if you want to delete data from the previous month or even year. Or maybe you had data forwarded to a specific folder for a system you no longer use, and you'd like to delete it now. Another somewhat manual method is to write a script to delete old data. There are also options to automate the process. We can set up the S3 event notifications to automatically delete data once it's processed, or we can create a lifecycle rule to delete the data based on a specific rule, such as deleting it after 30 days. I'd like to show a quick demo of these options so you can determine which is best for your organization. To manually delete data from our S3 bucket, we log into AWS, select our bucket, and select the folder we want to delete. I'm deleting all the alert data for a particular day, so I just have to drill down to the specific data I'm looking for. In this case, year, month, and then day. From here, it's pretty simple. You just need to select the checkbox, click delete, and confirm. Once you'll click save, you'll be able to see whether it went through, and if you want to verify, you can click close and check to see that your data is no longer there. Let's take a look at AWS Lambda. AWS provides useful blueprints to easily get up and running with Lambda. They provide an easy-to-get-started S3 GetObject Python script that will allow us to fetch files of the events as they are uploaded into S3. If we go ahead and click on this blueprint, we can give it a name, Live Demo Lambda, and then give it a role. The role will automatically receive the S3 object read-only permissions, which allows us to fetch the S3 file as it comes in. Now we can go ahead and select the name of our bucket. In this case, it's DevDay Live Demo. And all the object create events will be sent to this Lambda. But we want to limit it to just JSON-L zip files because there's a health check JSON file that we don't want to process. We can leave the trigger disabled for testing, or also if you wanted to develop this, it wouldn't be functional until you are done writing modifications to the code. So let's take a quick look at the Lambda function code that they've provided here for us. You have your entry point, the Lambda handler, that the Lambda service executes when it receives an S3 event. In this case, we will take the bucket and key information from the event and then fetch the object. In this example, the Lambda function just prints the content type, but we could easily forward this data into another database to be queried in a more searchable manner. Or we could process it and send another event out, or alert something if we need to. This is customizable to whatever functionality you need for your organization. Now we can go ahead and create it. It does take a few seconds to create. Now that we have the Lambda function, you can see that S3 events are being fed into our live demo Lambda function we created. If we scroll down, we can see the functional code that we saw before in a nice little editor that can be used to edit right here in the console. Now let's say we don't want to use AWS services to process our events. We can do another option, which is creating a simple Python script that does something very similar. In this case, the Python script will iterate through all the objects in the bucket. We want to limit it to the base path of the events to bypass the health check file just like we did in the previous example. From here, we will fetch the object and unzip it. In this example, once again, we are just printing the file contents to the console and then deleting it, so that we can treat this read as sort of a queue system in the future. As new events come in, like on a crime job, we can execute this Python code and process all the events that are within the S3 bucket at that point. So in order to execute this, we will actually need an AWS access key and a secret key. If we navigate to the IAM Management Console in AWS, we can find a user with correct permissions that we want. I've created a user with S3 full access, so we can select that user and navigate to their security credentials. If you don't already have an access key created for this user, you can create one here. Or if you happen to have lost the secret key for it, you will also need to create a new one at this time. There isn't an easy way to get that key once it's been generated. These keys are saved to environmental variables that can be used when the client and resource objects are created for that access. Let's go ahead and execute this code. We can pull up Python and run the S3 demo. We can see here that one of the files was fetched and unzipped, and now we're printing to the console. This will take just a second to go all the way through it. At this point, you could either push again to another service, possibly to another integration, or even do some more processing in the script if you need to. Lastly, we can create lifecycle rules in AWS by navigating to our S3 bucket, clicking the Management tab, and clicking Create Lifecycle Rule. From here, we just need to give the rule a name. This rule will delete data after 60 days. We want to apply the rule to all objects in the bucket because we want to delete everything. The rule action will be to expire the current version of objects, and we will select a value of 60 days. Now we just need to click Create. And we can see that our new rule has been created and enabled. Now that we have covered use cases and data storage, let's dive into how we can integrate the Carbon Black Cloud with other systems using the data forwarder. We have two pre-built integrations that can seamlessly push data to your other applications and also allow you to perform actions on that data. The Carbon Black Cloud apps for Splunk and IBM QRadar utilize the data forwarder, which supports endpoint events as well as alerted and non-alerted watchlist hits. These apps allow analysts to perform SOAR actions in Splunk and QRadar that extend to the Carbon Black Cloud console, allowing all actions to be completed from a single pane of glass. Carbon Black Cloud data is streamed in near real time to your S3 bucket and then consumed by Splunk or QRadar, eliminating the need to pivot between applications. This increases efficiency and allows your organization's analysts to focus on the things that matter. From these apps, analysts can investigate alerts and surrounding events, monitor watchlist hits, and take actions such as killing a process, banning or unbanning a process hash, and quarantining a device. The completeness of the data also enables you to create dashboards to view data from all your security systems, including Carbon Black Cloud, network traffic systems, and any others used to monitor the health of your environment. You may be thinking, what about those of us who use systems other than Splunk or QRadar? The beauty of the data forwarder is that since the data resides in an S3 bucket, it can be integrated with essentially any system that supports S3 data ingestion. So you can continue to use the systems you're comfortable with while also accessing additional essential data from Carbon Black Cloud.
Jasmine, you make a great point. We can integrate this data with a lot of platforms and customize it in many different ways. But why? How does this relate back to the threat scenario and what we've covered so far? I'm going to start with one thing first, around watch lists. If we can indicate on indicators of attack, so IPs, hashes, with a stream of data, why would I even need all this data in the first place? That'll give us an idea if we're being attacked from known threats. But that's the key detail, known threats. What happens when a new attack comes up and we need to go back in history and look at all the historical data to find whether or not we've been attacked through that vulnerability? Let's cycle back to the log4shell attack. This attack takes advantage of a lower level package, the logging package inside of a Java application, to reach out to an external location, in this case an LDAP server. that's the kind of core attack that we need to kind of capture and investigate across all of our Java applications, across all of our devices. This can be a very complex search, especially when we really just want to get a list of remote IPs. This would be something that we would do in a threat hunting search. We want to get those IPs so then we can go through and eliminate ones that are internal network connections or known customer interactions, anything that we can kind of use as like baseline. This would allow us to then eliminate a large portion, giving us what would be a much shorter list. But even then, in this situation, we may not want all of our Java applications. We may have patched it on a couple. We may not have. We may have identified that a few of our Java applications may not have been exposed or vulnerable to this due to different versions or different packages or different setups. So we could also take this filter and add additional filters to it. So instead of just looking at the process path java.exe, we could add a parent path. For example, let's say we were executing another Java application that was vulnerable from a parent one, such as a prod script or a different set of parent sort of executions. This would allow us to kind of really filter in and search deeper and find that list of remote IPs. And maybe we can then match it up to a future list where we have a known indicator. So in this case, we may not have been able to search for that IP directly, the list of known IPs, and instead we're kind of building that list of unknown that we can go through and eliminate. That's one kind of potential threat hunting search. Well, let's look at another attack, a DLL injection. We can use a very similar query as we did before with a very similar application, java.exe. We'd be looking for our DLLs, or mod loads in this situation. We could use the mod load name, but that would be a little more complicated to kind of find those distinct values. Using the SHA-256 provides very consistent behavior, but it will produce a non-human readable sort of output. We have all these hashes and a not very clear way of looking through them. We could again look at those known IOCs, but we don't really have that in this situation. We're searching in a threat hunting capacity. So let's look at a threat hunting practice. We want to find outliers. So given we have all the event data and we can do it across the devices and across the applications, we're able to drill in, kind of do a count in this case. We're able to group by the mod load SHA-256 in order to find those distinct values, but then we also want to find the count for each of those distinct values. We can also apply an order, so in this case, an ascending order. So we want to look for those outliers which have 1, 2, 3, 4 times that it was executed. Because likely, the attacker has not executed this thousands of times. Once he's in the system, he no longer needs to perform these module loads and do the DLL injection in each situation. And we're able to trim off all the ones of significant counts, those common or repeatable situations. So this is kind of one of those other mechanisms we're able to do with that event level data. There's potentially many more searches that you can do with the events, and this will kind of come down to whatever SIEM or tool you end up loading your data into. AWS, or rather S3, provides you many mechanisms to kind of interact with that data, and that's really kind of the core details and benefits of having the event data in AWS. So I'm definitely curious what you guys may have as potential searches or inputs you'd want to have as well. So if you want to know more, check out one of our many sources of content. We have our developer network, which has our API documentation, guides, as well as blogs. In this particular case, if you want our data forwarder API, there's a link right here on the screen. We also have data forwarder schemas as there, which will have all the data fields explained as needed. We also have Text Zone. This is kind of like long form content that may tackle a particular use case. You'll find some information there on Splunk, as well as other data forwarder use cases, such as advanced filtering, which was mentioned before. Last but not least, we have our VMware products. So if you're looking for more information on endpoint standards, enterprise EDR, audit remediation, or any of the other things that our Carbon Black Cloud backend can do, take a look there as well. Thank you for listening to this presentation. If you have any feature requests or questions, please feel free to reach out. We'd love to hear from you, and we're always looking for more input.